Hi, can you imagine a world where radiologists are empowered with the most advanced non-invasive image visualization tool? A tool providing them with actionable diagnostic information. We call it dVIEWR, a unique software solution using diffusion MRI to non-invasively look at microstructural tissue changes at an unprecedented level of specificity. When considering today's aging population and the increased prevalence of chronic disease, the desire for non-invasive diagnostic tools is obvious. Even though there are promising imaging modalities available today, they cannot accurately capture microstructural changes in tissues. Consequently, they are not specific enough to provide necessary information regarding distinct cell density, shape, and orientation to truly live up to their promise. With our advanced diffusion MRI methods, on the other hand, we allow clinical researchers to identify new imaging biomarkers invisible when using conventional methods. We believe that such biomarkers have the potential to replace unnecessary invasive procedures, such as contrast agents and biopsies. So, how did this all start? Believe it or not, we drew inspiration from the field of physical chemistry, traditionally remote from clinical diffusion MRI. In this field, samples are placed in a strong magnetic field and spun at high speed while acquiring data. This acquisition technique, called multidimensional diffusion nuclear magnetic resonance, enables one to isolate information related to the size, shape, and orientation of an individual sample's various components. We realized that similar information separation could be attained in the clinic by leaving the patient stationary and instead rotating the magnetic field gradients during the diffusion MRI acquisition. Through this novel acquisition technique, also known as multidimensional diffusion MRI, or MDD, we alleviate the lack of specificity of diffusion imaging, circumventing the use of invasive procedures with known side effects. This figure, showing two different brain tumors as published in Neuroimage by Dr. Stepankiewicz et al., clearly displays the increase in specificity achieved with MDD. Relying on conventional methods, the two tumors, although featuring distinct cell densities, shapes, and orientations, look similar on the conventional scan. Using MDD, the isolation of information imprinted by the tissue microstructure allows for tumor separation. At Memorial Sloan Kettering Cancer Center in New York, a group of researchers have compared MDD to conventional diffusion MRI methods in a breast cancer setting. While the image from the conventional scan does not reveal anything special, our MDD methods allow for tumor detection and for the study of the tumor's inner structure. For example, the inner structure of this tumor in particular can be intuitively read from the contrast color coding. Red indicates a shell of elongated cells surrounding a core of densely packed round cells, or necrotic tissue, in green. Before dVIEWR, analyzing MDD data was mainly limited to researchers with advanced computing skills. In order to make it accessible to more diverse scientific user groups, such as clinical researchers and radiologists, we have launched dVIEWR powered by MICE Toolkit. This suite of customizable software visualization and workflow analysis solutions are designed as an intuitive tool enabling anyone to correlate unique diffusion MR contrasts with specific microstructural tissue features. If you're interested in having the MDD acquisition protocols on your scanner or in obtaining a license for dVIEWR, send an email to support@dviewer.com or visit dviewer.com to book a demo. Thank you so much for watching.